Alright, what's up guys? In this video we're going to pick up with some calculus here, and this is going to be another example of some trigonometric substitution. So we're going to evaluate the integral x cubed over the square root of x squared plus 4 dx. So again, I'm not going to go into all the intricate details of trig substitution because I've done that in previous videos, so we're going to kind of just go ahead and tackle this one. So notice here that I have the square root of x squared plus a squared. And so obviously, this is going to be a tangent substitution, tangent theta. So remember, trig substitutions don't have to be under square roots. Most are, and those are easier to identify, but they don't have to be. So just keep that in mind. So let's just go ahead and tackle this one. So we know this is a tangent substitution. So that means that x here is going to be equal to 2 tangent theta. And we take the derivative of that. That gives us 2 secant squared theta d theta. And typically, if you're in an actual calc class, you can shorthand a lot of the stuff that I'm doing on video. And when I say shorthand, a lot of the extra writing and all of that stuff that I'm doing down, keep in mind I'm doing that for the purposes of the video. If you're in an actual class, you won't have to write all this information down. But for the video, I want to make sure I'm writing everything down so that everybody understands. So I'm not going to really be shorthanding anything. So I'm going to be plugging everything in. So it looks like we'll have 2 tangent theta up here. Remember, that's being cubed. And then we got our little square root down here. And we plug in the appropriate information. So it's going to be 2 tangent theta squared plus 4. And then we're multiplying that by 2 secant squared theta d theta. All right, so again, I'm not shorthanding anything, so let's do everything step by step. So we got 2 tangent theta squared plus 4. So that's obviously just going to be 4 tangent squared theta plus 4, which we know this just becomes 2 times the square root of tangent squared theta plus 1. We know that secant squared theta is equal to tangent squared theta plus 1. So this is 2 times the square root of secant squared theta, which you know is just 2 times secant theta. So when we take care of all the square root stuff, we get all that. So again, I'm not shorthanding. So I'm going to put all that information back on top just so you can see where everything is coming from. So don't forget that's being cubed. We're multiplying that by 2 secant squared theta. And then down here in our denominator, after we did all that simplification, we just got 2 secant theta down here. And all this stuff is being integrated with respect to theta. So now we'll do some canceling out. So keep in mind that there's 2 secants up here. There's 1 down here, so we'll still have 1 left over. 2 cubed is 8, so we can bring the 8 out. But the tangent is also being cubed. So that means that we'll have an 8 out here, and on the inside the integral in our integrand here, we'll have tangent cubed theta multiplied by secant theta d theta. That's where we're left now. So now we want to integrate tangent cubed theta times secant theta d theta. So again, you can break up tangent cubed as tangent squared theta times tangent theta. And we know that we can do tangent squared theta using a trig identity. We know that tangent squared theta, that's -1 plus secant squared theta. We know that. So that's 8 times the integral -1 plus secant squared theta. Don't forget about the fact that we still got an extra tangent theta, and the secant theta didn't go anywhere. And so now we got d theta here. Now when you look at this, when we go from this integral to that integral, it may seem like we made it worse, but we actually made it easier because now we can do a u substitution. And we know that the best selection for u here would be secant theta. And the reason why we know that is because we know the derivative of secant theta is secant theta times tangent theta. So the tangent theta will cancel out. So we get secant theta times tangent theta d theta. And then when we solve for the d theta part, we'll get 1 over all that stuff, secant theta times tangent theta. du is equal to d theta when we saw. So what we get is we get our 8 that's on the outside. Hopefully you see that the tangents will cancel out. And I'm gonna, probably isn't the best notation, but I'm just trying to show you what happens. So this would be -1 plus u squared, integrated with respect to u. So we can go ahead and take care of the integration. So that's going to be 8 times -u plus u cubed over 3. Now remember that u was equal to secant theta, so we just got to plug that stuff back in. So let me get another sheet. And in theory, a trig substitution isn't much different than a u substitution. It's just another substitution method for dealing with certain types of, or certain integrals with certain types of functions. Okay, so much like we would have done for a u substitution, we just go back to the original, what we originally had. So we got to plug this stuff back in there. So this becomes a minus secant theta plus, you can write it as 1/3 secant cubed theta. Once you put the theta stuff back in there, or the secant theta back in there. Okay, so this is where we go back to the fact that x was equal to 2 tangent theta. Now we know that since x is equal to 2 tangent theta, that means that tangent theta is equal to x over 2. We know that tangent theta from Pythagorean theorem, we know that's opposite over adjacent. So that means that that's going to be x over 2. And so basically what we're missing is the hypotenuse, which we know we need. So this is where Pythagorean theorem comes in. A squared plus b squared equals c squared. So you just stuff the stuff in there. So we'll just get x squared plus 4 is equal to c squared. If we take the square root of both sides, we'll get that c is equal to the square root of x squared plus 4. Why do we need to do, and sometimes it's helpful to draw a little bit of a triangle. It isn't required, but sometimes it's helpful to draw a little bit of a triangle just so you can kind of see what's kind of going on a little bit. So we know the opposite side was x, the adjacent side was 2, and now we have the hypotenuse, which is x squared plus 4. Now, why do we need all that? Well, the reason why we need all that is because we know that secant theta, remember, that's hypotenuse over adjacent. And so if we didn't have the hypotenuse, if we didn't figure out what that was, we never could have determined the ratio. So now that we have all the information we need, we know that secant theta in this case is going to be equal to the square root of x squared plus 4 all over, basically all over adjacent side, which is 2. So if we go back up here, where we were at. So remember that theta, this really isn't all that necessary because we already did this side, but just in general term, if we wanted to solve for theta, we know that would just be arctan of x over 2. It's really not really all that necessary, but just kind of pointing that out. So if we go back to the information, that means that once we start plugging this stuff in, again, the arctan stuff, it wasn't really all that necessary, but I was just mentioning just in case you wanted to solve for theta. So if we start substituting all this information in, we'll get negative square root of x squared plus 4 all divided by 2. And then that'll be plus 1/3 times the square root of x squared plus 4 all over 2. And that's being cubed. We gotta close all that stuff up. So perhaps should have made the parentheses a little bigger. Okay. All right. So what do we get here? So the first thing that you should notice is that 8 over 2 is 4. There is a negative there. Keep in mind that 2 cubed is 8. So if I went ahead and distributed over, the 8s would, just reduce down to 1. And anytime you cube a square root, that's the same thing as raising it to the 3 over 2. So effectively, the answer here. I'll just go ahead and write it, just kind of kill two birds with one stone instead of going through all the minutia. Final answer. So we're asked to integrate x cubed over the square root of x squared plus 4 with respect to x. So the answer to this is going to be negative 4 times the square root of x squared plus 4 plus 1/3. Again, cubing a square root is the same thing as raising it to the 3/2. So that'll be x squared plus 4 raised to the 3/2. Well, actually, you get rid of the square root, of course, and just raise it. Do x squared plus 4 raised to the 3/2. And then you tackle on a plus c. And that would be the answer for the integral itself. And that's how you do the simplification. So hopefully that made sense. I'll circle the answer here. And like I said, if you have any questions about this, just let me know. Trig substitution does require that you have those trig identities memorized and that you're pretty good with this Pythagorean theorem stuff. Make sure you got that stuff down packed. But that's example number 2, and that's how you do trig substitution. So let me know how the explanation on that went. Give me some feedback. Let me know if you have any questions, and we'll talk about it. I'll see y'all next time.